Okay, so the next doubt is when 2 point charges Q and 3Q held at a distance r from each other are released, they have an acceleration of a and 2a. Okay, so you have 2 point charges Q and 3Q separated by a distance r. They are released and they have an acceleration a and 2a. You see, acceleration depends on the force. And the important thing is in Coulomb's law, remember, force between two particles will always be in Coulomb's law and in gravitation is same. So force is k q1 q2 by r square. So the force only depends on the product of the two charges. So whenever you have two charges interacting, forces will always be equal and opposite. That's the important thing. So which means whatever force is acting here, F will be the same force acting here. They can have different charge, different mass, doesn't make any difference. Mass different, it will give me different acceleration. But irrespective of whether they have same charge, same sign, different sign, magnitudes will be same, directions will be different. That's the key idea. Same for gravitation and same for electrostatics, equal and opposite forces. Okay, so here, what is the acceleration of this? So here you say acceleration, for example, this is, I take it as the first object, for example, m1 and m2. So the acceleration for this F is equal to m1 a1. The same F is equal to m2 a2. Okay, so here they say acceleration a1 is a, a2 is 2a. Okay, fine, I can substitute. So both of them are equal. So let me have F is equal to m1, I don't know, a1 is a, f2 is again f, m2 I don't know, a2 is 2a. Fine, we can find m1 and m2 by equating. Let's see, when we distribute the total charge equally, so total charge is q plus 3q 4q equally if you distribute, which means 2q to q. Fine, between them, keep them at the same distance. So let's do that. So I have two charges. Now it is 2q kept at the same distance. And you see, here I'm going to assume mass doesn't change for charge. Okay. So charge can be varied without a big difference in mass. We can just rub something, bring them in contact. So the charge can change without a considerable change in mass. Okay, I'm going to assume that because only electrons can be exchanged, negligible mass change. Original release, then their acceleration now will be. So the new acceleration. Again, you have to remember the forces will be same, but now the force is different because the force depends on the product of the charges. So the new force, let's say F prime, same F1 will be equal to F2, forces will be same. The new force will be equal to K Q1 Q2 by R square. So the new force is 4KQ by R square. This is F prime. Okay, what was the old force? Let's write it down. So the old force is K, product of the two charges, Q into TQ by R square. So the old force is 3KQ by R square. Now if I need to find acceleration, okay, I can find the force and then I can find the acceleration. Now what I get this is, you see, if I divide F by F prime, I don't want to do it here. Let's look at this here. If I divide F by F prime, as you can see here, F by F prime will give me everything will cancel except for 3 by 4. So the new force is, or let's say F by F prime is 3 by 4. Let it be that. Okay, let it be here. There are multiple ways to solve this. Look at this. If I write the equation, Newton's law, F is equal to m, F prime is equal to m1 a1 prime. F2, which is again F prime, is m2 a2 prime. What I'm going to do is I can divide these two. Okay, so let's say, I hope you can see this. Okay, so I'm going to divide these two equations. When divided, it will give me F prime by F is equal to m1 a1 prime by m1a. M1 cancels. F prime by F is 4 by 3. A prime I want, A is A. So it is 4 by 3A. So A prime or A1 prime maybe, okay, A1 prime is 4A by 3. This is A1 prime. So there is only one with this. We have an answer, but let's continue. So the same thing I'll do here. So again, if I divide these two, it is F prime by F is equal to M2 A2 prime by M2 into 2A. M2 M2 cancel, F prime by F. F prime by F is 4 by 3. So 4 by 3 is A2 prime by 2A. So 8 by 3 is A prime or A2 prime. So 8 by 3. This is the answer. So the key idea in this problem is that forces will always be equal and opposite irrespective of the total for a given pair of charges. And you know the formula. And then you solve it normally. And here another assumption is when you change the charge, mass is not changing that much because you can just move few electrons for it. Electron mass is negligible. Hope this is clear. And you see, if you don't post the doubts in our Telegram channel, then it takes some time for me to see it and then remember and do it. Okay, so if you want doubts cleared, then and there, post in our Telegram channel. It's link in the description. If you like the video, hit the like button, keep practicing. Okay, all the best.